Okay, so that was it. Let's take a look at there's a reading right there that you just read. There's a diagram. Hope you got to take a look at it. It is, I'm going to show you, and that's actually pretty simple what we're going to do, but it's easier when you see it done. Now, hopefully you read all this. You maybe took notes, and and you have some familiarity with this because I talked about it last week. Okay, what it is the lytic cycle right here is this is where the virus takes over the bacteria, or doesn't even have to be a bacteria, it could be a eukaryotic cell like a human cell. Okay, and right, Andrew, I'm showing you the pages that you need. Okay, so after you read this, then you come over here and we were looking at the lytic cycle. So we want to compare this cycle to this cycle right here. And if you look at it, these things right here, it starts right here, okay? So these two things happen in both the lytic cycle and the lysogenic cycle. The lytic cycle is when the virus goes in there and it takes over, and then it replicates the virus, and then once you get so many viruses, it blows up. Okay, so that's called the lytic cycle. Now, the lysogenic cycle, these two things happen, but then instead of going over to the lytic cycle, then it goes over and it forms a provirus. Okay, and when it forms a provirus, the virus, you can't see the color that well, but the virus right there becomes part of the viral DNA becomes part of not a chromosome, but part of the bacterial DNA. That every time the bacteria DNA replicates, then it also replicates the virus DNA. So it's a tricky way for the virus to make more and more and more and more copies of the DNA, of the virus DNA. And then finally something's going to trigger it. And that trigger then causes this cell to stop from going to the lysogenic cycle, and it'll go into the lytic cycle. The lytic cycle is when it turns on and it makes all these things right there. So what we're going to do is make a diagram that summarizes that. So let's go over to my document camera. Okay, there it is right there. All right, that's a little big. So a Venn diagram is, you may know better as a double bubble, okay? Or you may know it from math. So, when you're studying properties in math, you often go into that. So here is my camera, my document camera, and let me see, got these wires in the way. Okay. I've got line paper, but to do this right, I think you need to turn it. So I'm going to go ahead and do it on some printer paper that I grabbed out of the printer. So this is what you're going to do is you're going to compare the two. You're going to compare the lytic cycle with the lysogenic cycle. Okay. Lysogenic cycle. So if you have the diagram handy, I have the diagram handy in my book over here. Okay. You also, again, if you don't have a book, I may put a picture of it on the assignment so you can see that and you can compare what we're doing to that diagram on page 529. Okay. So let me see. All right. So on the lytic cycle, what you see is actually, no, lytic cycle. Let's go over here. Okay, there's my book instead of what was on the screen. Again, these things happen in both of them. And then it either goes into the lytic cycle, which is this way, or the lysogenic cycle, which is that way. Okay, so So both the lytic and lysogenic do attachment. It says virus attaches to bacteria cell. That's the virus right there. Looks like a spaceship, right? And that spaceship attaches, and then the nucleic acid that's inside the protein head is going to be injected right there. And so it says entry. It's also called injection. Viral DNA enters the bacteria cell. So you're going to have both of those happen in both the lytic cycle and the lysogenic cycle. Well, in the lysogenic cycle, then the virus goes to sleep. It's also called the sleep cycle because really, here's the viral DNA right there. It becomes part of the chromosome. We don't even call it chromosome. It becomes part of the bacteria DNA. And then you can see anytime the bacteria reproduces, you get more and more and more of those viral DNA. Then something happens, and then something triggers the release of the virus from the bacteria chromosome, and then the virus gets read. Well, this doesn't always have to happen, but you can see this is a really easy way to reproduce a lot of the copies of the viral DNA. So it's a good thing for the virus to do this. But then when you get that signal, then you're going to make the parts and you're going to assemble them. Okay. All right. And then finally release. So that's the end. When you get so many of these, then it blows up. For certain viruses, we know what's called the burst size. We know when they're going to explode, and so they go over there and they stick. Like for an E. coli bacteria, there's a certain virus. When it gets to about 100, then it blows up like that. And so we instead of saying it blows up, it's release or bursts. Sometimes they just get squirted out a little bit at a time. Through the process of exocytosis that we studied, first semester. Well, that's another thing. Okay, so let's make our diagram. I'm going to set it up with you, and then you're going to fill in the rest. Okay, because I don't want to do everything for you, but we'll do this part together. So we have the lytic cycle, and this is called the double bubble, right? Because what you do is you draw a circle right there of characteristics. If it's in the purple circle, those are characteristics of the lytic cycle. And then the lysogenic cycle, these are characteristics of the lysogenic cycle. But what we're going to see is that there's some things that are in both of them. Now, if you look at the diagram from what I just said, and I'm just going to write the bold term right here, but you're going to fill in all the rest. Okay. So I know you did the reading, but I would take it straight off of this, straight off of the diagram here on page 529, because what happens in both of these is attachment, okay, and also entry. And then what happens is if it goes to the lytic cycle, there's replication, there's assembly, and I'm just getting the bold terms off of page 529 and release. You're going to add the details to it. Okay, so if you look at just the lytic cycle, here's the diagram again. Oops, knocked the camera out of the way. There you've got attachment, entry, replication, assembly, release. Now, what happens in the lytic cycle is it goes over here, starts over here, and then over there. Well, this happens in the assembly and replication. You can say that happens in the lysogenic cycle as well. So let's go ahead and do that. So we have, all right. So what? Oh, there goes my diagram. Hang on. A little bit of wind right there. That's the wind blowing my work away. Okay, so you got attachment and entry, replication, assembly, release. That's what you see for the lytic cycle. Now let's do the lysogenic cycle. The lysogenic cycle also has attachment and entry, and after that, it goes to provirus formation. provirus formation. The next thing that happens. Okay, so over here, what you have is you have attachment, entry, and then here, right here, is provirus formation. It starts going around there into cell division. So let's go to cell division. Also happens in the lysogenic cycle. And then they say that, okay, well then something in the environment triggers and it goes into the lytic cycle. So in a way, the replication, assembly, release also happens in the lysogenic cycle, but from a scientific point of view, we just say that the cell goes out of lysogeny and goes into the lytic cycle. So at this point, then we're no longer in the lysogenic cycle. We're out of the lysogenic cycle. So it almost stops right there. And it's just that we say, now this goes into the rest of the lytic cycle. So I think for my diagrams purposes, I'm going to say that I'm going to leave it like this. But to finish it off, I'll say the provirus leaves the bacteria. So I'll just write provirus leaves. Now, when you did the reading, it had all this stuff, so you can add the detail. But the one, they did give us an example of the lysogenic cycle, and we said that it was a latent or dormant is another word for it, a dormant infection. And then over here, we say that it is an active infection. And that's from the text, not the diagram. But if you read the text like you should have, you have some information about this. I would add some examples right there, but I'll leave that to you. Okay, so now you got the basics of the Venn diagram. And I want to give you a little bit more time to finish this up and give us the details about replication, what that is, and what assembly is, what release is. Up here, starting over here, it's attachment and entry. You start over here, you can see there's some information about attachment and entry. You could write that in if you wanted to, or you could put in your own words, or you can grab something from this part of the text over here. So it's pretty easy to do, but then we'll be done and you can check this off. I'll give you 10 more minutes to do this, okay?